In a library in Cambridge, there is a paper, published in the spring of 1920, with one photograph bound into it. It is not much to look at. A white disk where the sun should be, a dark crown of flame around it. The plate is a negative. Every light in the sky is written as its shadow, and a handful of faint dots. Those dots are stars that should not be where they are. Each one sits shifted, ever so slightly, from where the same telescope had photographed it on an ordinary night. Not because anyone measured carelessly, because starlight, passing the sun on its way down to Earth, had been bent. Space itself curves around anything heavy enough, and in that spring, the idea belonged to one German physicist, and it was still only an idea. The men who made this photograph chased a total eclipse across the world, 2 teams on 2 continents, because if the weather broke over one, the other might still see. Clouds sat over one camp until almost the last minute. Then the sky opened. When the measurements were read out in London that November, the man in the chair called it the most important result about gravitation since Newton. By the next morning, the German was becoming the most famous scientist alive, and the glass the photograph came from, some of it is lost, some of it is broken, some is locked in an archive no one can open, and in Brazil there is a room of it, slowly fading. This is the story of the picture that bent the universe, and how close we came to losing it. Glass, not film. Film stretches as it dries, and this measurement cannot survive stretching. The shift they were after is a fraction of a second of arc, a coin held up 3 miles away. The sky could give exactly 3 answers. 1. It goes straight past. Gravity does not touch light, and nothing changes. 2. It bends by 9/10 of a second of arc, falling the way a stone falls because the sun pulls on it. Space is flat. Newton survives. 3. It bends by 1 3/4, twice as far, because the sun bends the space the light crosses. Newton is not adjusted. Newton is replaced. 3 numbers, 3 universes. And here is what gets left out. The middle number is Einstein's own, published in 1911, before the theory was finished. When he finished the theory in 1915, curved space-time added a bend of its own, just as big, and the prediction doubled. Astronomers had gone out for this 3 times before and been beaten by weather and by the war. If any of them had succeeded, they would have brought home the half value and buried the theory that replaced it. The failures were the luck. Then the calendar produced the one morning that could settle it. In 1917, the Astronomer Royal, Frank Watson Dyson, pointed at an eclipse 2 years out, unusually long, with the Hyades behind the sun. A crowd of bright stars, where most eclipses give a thin field. There was one problem with 1917. Britain was at war. Eddington was 37, director of the Cambridge Observatory, and a Quaker who told a tribunal in 1918 that he would not fight. Dyson intervened, and the tribunal exempted him for 12 months to lead a British party to the eclipse. So the Englishman who would not fight Germans was released by the British state to go and test a German. The armistice came that November. Eddington did not take an astronomer. Both of the assistants at his observatory had been killed in the war. He took a clockmaker, Edwin Cottingham, a shoemaker's son from a North Aintonshire village, who had overhauled the clockwork that keeps a mirror following the sun. The other party went to Brazil. Cromiel, It and Davidson of the Royal Greenwich Observatory with 2 cameras. The big one was Greenwich's own 13-inch. The small one, a 4-inch lens on loan from a Jesuit priest, Father Aloysius Corti, with a mirror borrowed from the Royal Irish Academy. Corti could not spare the time to go, so Cromwell Inn went instead. Remember the borrowed lens. A Brazilian party hosted them at a race course in Sobral. Local labor built both stations and was credited in neither report. Neither party got to choose its weather. 2 camps, 2 continents, 1 morning. The island first. A thunderstorm ran over Príncipe all morning. Totality was just after 2. and the sky cleared only shortly before it. Cottingham ran the mirror. Eddington changed plates, 16 exposures in 5 minutes, and he could not see what he was getting. Through cloud, a black disk still shows, stars do not. He developed them 2 a night for 6 nights, and wrote home, quote, "The one plate that I measured gave a result agreeing with Einstein. Here is what the report does not say. That plate has a letter, not a name. Plate U, 2.9 seconds of arc, plus or minus 9/10, an error bar wide enough to swallow the question. In London, it was judged too uncertain to use and cut." The most quoted moment in this story never made the report. Of 16 plates, 2 could be measured at all. 3 weeks later, they left early to get ahead of a threatened steamship strike, which meant they never photographed that star field from the island at night. No comparison plates. Hold on to that. Brazil was clouded over at the start too. Moments before totality, the sky cleared and both cameras ran. 5 minutes and 13 seconds, one of the longest eclipses of the century. And then the main camera failed. Developing on site, Davidson found the big Greenwich astrograph had lost focus during totality. The star images were smeared. His diary, quote, "It seems doubtful whether much can be got from these plates. 6 weeks later, they went back before dawn for the comparison plates and found it in perfect focus. Whatever went wrong for 5 minutes, once, and left nothing to correct against, which left one camera in the whole experiment still standing." Measuring began in September at Greenwich. Davidson measured. Ferner measured. Dyson directed. Eddington was not in the building. His handwriting appears nowhere in the Sobral notes. Dyson's is throughout them. The 4-inch lens at Sobral, 7 plates, 7 stars, 1.98 seconds of arc. Príncipe, 2 plates, 5 stars, and no night pictures from the island to compare them against. 1.61, so an error bar 2.5 times as wide. Not 0, not the half. Both outpassed Newton, the better of the two just above Einstein. Eddington found out by post, quote, "I am glad the Cordy plates gave the full deflection, not only because of theory, but because I had been worrying over the Príncipe plates." Then the third set. The smeared plates gave a smaller number, and how much smaller depended entirely on what you assumed had broken. One way of working it gives 0.93, another gives 1.52. The report quoted no error bar at all, because nobody could say how wrong the camera had been. Dyson set them aside and said so in print, quote, "The greatest weight must be attached to those obtained with the 4-inch lens at Sobral." The paper itself says Eddington's plates were not the ones that decided it. 61 years later, 2 philosophers of science, John E.R. Mann and Clark G.L.Y. Moore, argued that the negative result had been suppressed. Hawking repeated it. It is now the thing most people know about this experiment. Take it seriously, then look at the record. Eddington did not make that call. Dyson did. And Dyson was no believer. He wrote, months after announcing it, that the result was contrary to his expectations, and those plates could only back Newton if the camera had genuinely broken. Assume it was merely out of focus, and the same glass gives Einstein. In 1979, the Royal Greenwich Observatory pulled the surviving plates out of storage and measured them again by machine. The 4-inch came back at 1.90, the astrograph at 1.55, Dyson's own alternative number, 60 years on. That paper has been cited almost nowhere. The accusation is in every popular account. None of it was known in the room. On the evening of the 6th of November 1919, there were 3 numbers, a chairman, and a picture on the wall. A joint meeting of the Royal Society and the Royal Astronomical Society at Burlington House. In the chair, Joseph John Thomson, who discovered the electron. Dyson read the numbers and finished like this, quote, "After a careful study of the plates, I am prepared to say that there can be no doubt that they confirm Einstein's prediction. That sentence, not anything of Eddington's, is where Newton's monopoly ends. What gets dropped from the chairman's verdict is its first word, quote, if it is sustained that Einstein's reasoning holds good, then it is the result of one of the highest achievements of human thought. If the president of the Royal Society announced a revolution and hedged it in the same breath, It was not a coronation. It was an argument. Ludwig Silberstein said the bending of light was an isolated fact. Einstein's theory made one more prediction, and nobody had found it. He was right. It was not found for another 40 years. Then he pointed at the wall, and the reporter printed the gesture in brackets. Quote, "We owe it to that great man," pointing to Newton's portrait, "to proceed very carefully in modifying or retouching his law of gravitation." The man being corrected was in the room, hanging on the wall, and somebody pointed at him. Then Eddington answered the objection. Quote, "In this case, it is Einstein's law of gravitation. It is not necessarily his theory that is confirmed." Eddington, on the night, told them the experiment did not prove the theory. The next morning, the Times of London, "Revolution in Science, New Theory of the Universe, Newtonian Ideas Overthrown." American front pages had it inside 3 days. On the 10th of November, page 17 of the New York Times, "Lights all askew in the heavens." The most famous science headline ever printed opens by admitting nobody could explain it. There is no byline. The correspondent had not been in the room, and in the same column it calls him a Swiss citizen, about 50 years of age. He was 40, and you have been hearing him called a German since the first line of this film. Within 2 years he came ashore in New York to crowds. The man had an easy century ahead of him. The glass did not. Lost. Not one of Eddington's Príncipe plates survives. Plate U, the one that agreed with Einstein, the one that was cut, went with them, broken. When the boxes were opened in 1978, 2 plates were missing, one was broken, and some had discolored, locked. The Sobral originals, the plates that actually decided it, do survive, in spite of many statements to the contrary. That last phrase is the scholar's own. They sit inside a mass of more than 100,000 glass plates at Oxford, uncatalogued, unavailable for research, and fading. In Rio de Janeiro, the Brazilian expedition's own collection runs to 948 plates. 61 have been restored. Many of the rest show silvering, emulsion loss, and fractures, the record coming apart while it sits. So look again at what you have been looking at this whole film. This is not a photograph of surviving glass. It is a halftone, the picture rebuilt out of ink dots, bound into a paper in 1920. In 1919, copies of one plate were made and sent to observatories around the world, so that other people could check the measurement themselves. A century later, one of those copies was scanned, and that scan is the sharpest picture of this eclipse anybody has. The original is in a box nobody can open. The copy is on your screen. Newton survived too. He was not thrown out. In ordinary conditions, the 2 theories agree, and Newton is still what puts a spacecraft where it is aimed. What changed was what gravity is, and one eclipse with 7 stars on it settled nothing by itself. That took an Australian eclipse 3 years later, and everything since. The people who hedged were right, so a record is not the object. Glass breaks and silvers and gets misfiled. A record is the copy somebody bothered to make, the paper somebody bothered to print, and the sentence somebody bothered to write down in brackets because a man in a room pointed at a picture on a wall. The picture bent the universe. What kept it was ink.